Hello everyone, this is the Mining Geologist and I'm back again with another very exciting and very informative tutorial. In this tutorial, we are going to see the basics of bit optimization, but I know in the mining industry, when you hear the word bit optimization, there's only one package that comes to your mind. Well, that's not the case for this tutorial. We're not going to cover that package, but the thing is that there's this misconception. There's only certain tools that are able to do things like, I don't know, like for implicit modeling, there's specific tools that are everyone thinks that they are the best, and for bit optimization, they think about certain packages that they are the only ones in the industry that they does bit optimization, but that's not true. It's everyone is doing that based on some historic data. It's true that some packages, they started the thing. They were the only packages in the past that were doing bit optimization. So everyone is thinking that still until 2022 they are the only packages that are doing that, but that's not true. And all of these packages, they're using the same algorithm that was developed back in the 90s. So all of them will generate pretty much the same results. And now what makes the difference is how easy it is to generate these results. And today we are going to see how you can do bit optimization easily in Micromine. So in this video, I'm going to assume that you know what is bit optimization, the basics of bit optimization, how important it is in the mine planning process and in the mining in general. And I'm going to just show you how you can do that using Micromine. Okay. And if that's not the case, if you're not familiar with bit optimization, please pause the video and you can Google that and you will find plenty of articles and documentations about that process. So in Micromine, you can see with the starting from the version 2021, we have the ribbon menu, and it's a great thing in Micromine because now when you look, now we're doing a process part of the mining, and you can see that the optimization is actually the first step that we need to do. So and the next thing you can see that we have mine design. So we're going to take the shells generated from the optimizer and take them to the mine design tools to get like detailed design, and then we can jump to like grade control and maybe scheduling. So you can see that even if you don't know the process, if you go to any one of these menus in here, Micromine is going to guide you through where to start and what is the ending phase. In our case, we're going to start with bit optimization in this tutorial, and for that we'll need some economic parameters related to extracting the mineralized ore body, or like all the different wastes and the costs and revenues and things like that, so that we'll be able to assign some values to the block models. And we will need also some geotechnical parameters. That's how, what are the slopes that you are going to use for different regions, and are they all the same, or there are some regions in which you are going to use specific slopes. I'm going to cover that in the form of the bit optimizer. So if you go to the mining and then bit optimizer, yeah, by the way, as you can see, we have a pretty basic data set in here. We have a DDM topography, and underneath that one we have a block model. So this is what we are going to use for today's tutorial. Of course, the first thing that you should do is you need to look at the different grades in the block model. What are the high grades? Where are they located? So later on, when you generate some shells and maybe you create like different stages, that's what we call a micromine, or maybe someone else would call them a sequence. So you have like a very shallow shell in here. You know that And when you filter by by grades in Micromine, notice that the high grades are in this region, so you know what you've done is the right thing. So I'm sure that if you're familiar with bit optimization, that's something that you would do before starting this. Okay, so we need to go to Bit Optimizer. You can see that we have two different things in here in the resource optimization. We have the Stope Optimizer and we have the Pit Optimizer, and they are almost the same, but one of them is for open pits, the other one is for underground mines, and you have stopes and things like that. We're going to cover the Pit Optimizer, but if you're familiar with, for like the for open pits, but if you're familiar with one of them, the other one is going to be like really straightforward and easy to customize to your needs. So let's go and click on Pit Optimizer. Okay, I've got some parameters in here, so we don't have to type things, but I'm going to walk you through all of these. So when you open the Bit Optimization setup here, in this form, you'll notice that we have 3 tabs. The first one is called Mine, and we need a name for this one. This is basically, you need the name and a code for reporting later on when you generate reports, so you know that maybe you'll have like different pits or different scenarios. So you can follow with the codes and the names of that you've set up in the Bit Optimizer, and we have the definition here, in which we are going to have a different tab or different form in here, in which we are going to define all the parameters that we are going to use. So let's start from the top. You can see that we have model, we have design, and we have output. So we have some data or inputs that are related to the block model, and we have data related to the design, and then the outputs. So let's start from the top going down to the bottom. So the model, basically, this is the block model file, and everything in red, it's mandatory. Everything in black, that's just optional, but if you have the data, it's better to use it. So for example, if in your block model, if you have a density field, make sure to use that, because if you don't have a density field, you will need to use like one density for everything, so which is not very accurate to do. So you can see we are going to import the block model in here, and this is going to be generated automatically most of the time. This is the east, north field, and Z field of the block model. So if they're not called with the default names of that Micromine uses, like east, north, and RL, so make sure to go and check whatever field that corresponds to this one, and there you go. So then we have all the different fields in here. And the next thing is, so sometimes you have like a full block model, which means that we have all the waste material and all the way to the topography, and you have the ore body, and everything is included in one block model. In that case, you don't need a topography. You just tell the software that I have a full block model, which includes the topography and the waste material and everything. In case you have a block model like this one, which includes only the ore body, in that case you will need to use a topography or a DDM. So we're telling the software that we have a topography and it is inside DDM, that's the triangulation database, and the wireframe is called topography. So you can go and navigate to whatever DDM that you have in there. Okay, now if you want to limit the optimization to a specific region, so you can go and use custom optimization limit and use this one. You can calculate this automatically if you want, and this is going to look at the limits of your model, and they're going to be already filled in here for you. But if you want to use a custom limit, you can type it in here. Maybe you are interested in just optimizing certain region, or whatever is the reason you want to do that. So you can do that, or you can just uncheck this one and do an optimization for the whole thing. Now for the optimization value, this option is by default set to calculate from element revenues and costs. which means that you will need to define the different revenues and costs related to each block, whether it is a waste block, an ore block, a high grade, a low grade, and so on. And if you want to do something custom, you want to try things, so you have your own formula to that your specific mine, you can go and use a value from field, and you can just click on this one and use expression instead, and you can define something in here. So you would say, like, for example, maybe you have like a percent block, which makes things complicated with optimization. So you can say, for example, look at that, the value in the volume, for example, multiply that by the density minus this one and plus this one. So you can define a very complex formula in here to calculate the value of each one of the blocks. But by default, you need to use the calculate from elements, from element revenue and cost. So this page is already set up, so we can go to material bins. So basically the material bins are, how do you want to divide your report later on? So you can divide it either by rock type or by, if you have maybe classes, you can do it by class, or you can do it like, for example, in this case, low grade and high grade, and you can see that our deposit is a gold deposit in this case. So basically you set the name for that material bin and you set a code for that, and then you apply a filter. So the filter, you say, for example, what do we consider a low grade in this case? Maybe we're going to say that everything that's with a grade greater than 0 and everything that's less or equal to 1.5. So this is the interval of the low grades, and we can go and save that form as, and we're going to get that so that later on the reports are going to be divided to these two different material bins, and we can assign different costs based on these material bins. So you can see also we have a high grade in here. So if you hover in here, you can also see that everything that's above 1.5 is considered a high grade, and you can go and add and make it as complicated as you want. So you can go also and add filters. It needs to be this material, this rock type, for example, and the grade needs to be between this and this interval. So you can do whatever you want, or you can do also expressions if you want to make things complicated. So for the elements, basically in our case, our element is gold, and this is the field. You need to check the field in which you have the different grades. That's the case for us. It's the AU, that's for the gold, and the grade unit is basically gram per ton. So you need to check whatever grade that you have based on the element you're optimizing for. Of course, you can apply some dilution factors in here, but we can do that later on. So for rock types, if you have, in our case here, we don't have the lithology in the block model. So as an example, we're going to use the class for the different rehabilitation costs. We're going to say that we have a 0.4 per ton. That's rehabilitation cost for the measured, 0.4 for the indicated, and 0.4 for the inferred, or we can just ignore this if we want. Now, some of you might be asking, 0.4 what? Well, that's something that depends on you. It could be $0.4, it could be 0.4 pounds, it could be 0.4 Canadian dollars. So just make sure that whatever value you want to use, so if you used, for example, US dollars in here, you need to use US dollars everywhere. So you cannot set this, for example, as Canadian dollars, and then you move to the selling cost and you use, for example, I don't know, euros or whatever currency that you choose. So make sure you use the same currency for all the different costs and revenues. That's one thing. Okay. Now the next thing is basically the dilution recovery, and you can see that you need to always set a default value, because when Micromine is going to look at the dilution value or a factor, and there's nothing assigned to the to that block model, it's going to use that that default value. So in our case, we have 15 for this one, and that's 15%. Or you can use factor and use, for example, 1.15, or that's how we use factors. And in our case, we're going to stick to percent. And we have recovery losses, that's 85%. And if you have a field for that, you can use the field, and that's going to make things more accurate. And of course, if you go for accurate things, that's also going to take some time to process. Now we have the defaults in here. So these are the defaults that Micromine is going to use if there's no value for that specific thing. So for example, if there's no density field, Micromine is going to use 2.2. Or maybe if there's a density field and there's a block with no density or something missing, Micromine is going to use that default value. And also for these different factors, the different mining factors and processing factors and things like that, they're set to 1, which means that they're not going to be used. They're just 1, so everything's multiplied by 1. And you can assign some factors if you want. But also, this is for the ore and this is for the waste. And yeah, so we're setting the rehabilitation cost to 0.2, and these are just the defaults. Now we've finished with the model, so these are everything that you need to set up for the model. And you've seen that it's not really that complicated, and it's really fast to set up once you have like all the data that you want to use for your optimization. So let's go and skip this one and go to the design tab. And basically you can see now for open pit, you can see that we have the design open pit mine in here. So we have all the different costs. This is for the cost for mining, the ore, which means that we have like $3, for example. Let's say that the currency is dollar, $3 per ton for the ore, and we have like maybe $2 per ton for the waste. And you can just check this one if you want to say that this one includes the dilution and recovery if you want. And you can change this to cubic meter if you want, but you can set it to ton, which is the default one. Now for the slope restrictions, like I've mentioned before, you need to do some geotechnical analysis and some slope stability analysis. So you look at some regions, maybe it's safe to use like 60 degrees, for example, for the overall slope, and some other regions, like maybe there's a fault or something that you cannot go to 60 degrees. Maybe you want to use like just 45. So you can define these regions based on, in 3 different ways. So you can use the min-max coordinates, which are not the best way to do it, because this is basically if you have min-max x, y, and z, basically that's going to define something squarish. Maybe your region that you want to define is, there's a complex shape, and for that case it is better to use wireframes. So basically you create a wireframe for that region that covers that area of interest. Maybe you can create a wireframe for 45 degrees, another wireframe for 30 degrees, another wireframe for different slope, and then you can set that slope in here. This is going to be the default one, as you can see that this is default, and this one you're going to use this specific angle. So let's go and edit this one. For example, you can see that the bearing is 0 and the slope angle is 48. So if you use wireframe, you're telling Micromine if the shell that you're going to generate is inside this wireframe, then use this angle. And by default, use this angle, which is 40 degrees. And you can add as much as you want. So this is the easiest way to do it. But we're going to use something very simple in here. And we're going to use some min-max coordinates. And that's it. Or if you have, which is something even easier, if you have maybe some specific lithology that you want to use a specific angle for that, you can go and do that in Micromine or whatever software that you have. You're going to say, like, for example, if you find this, if the lithology is equal to this lithology, use 45 degrees. Other than that, use, I don't know, like 35 degrees or whatever, and that's gonna populate, you know, a new attribute in your block model, and you can use that here. You can use the slope field to, you know, make Micromine decide which slope is going to be used in that region, which is another easy way to do it, but we've chosen to do it the hard way here and use some min-max coordinates. Okay? So, so we're going to use this one just by default, and that's it. So exclusion zones. So basically, if you remember in the model here, we said in the beginning, we said that you can do some custom limits, but as you can see, we've defined them as min-max coordinates. And again, that's not something very custom. So if you want something, maybe you have an area that's already mined out, or an area that you're not interested in optimizing that one, you can define that here in the exclusion zones. And we have two ways of defining that. It's or maybe three. So you can see that, sorry, two. So we have the polygons and wireframes. So you can create a string that delineate an area in here, and you say that that zone is going to be excluded, or you can create a wireframe that covers the area that you want it to be excluded and set that wireframe here, and Micromine is not going to include that region when it is doing the optimization. So we're not excluding any zone in here, but we just wanted to show you how that works. Now for staging, basically what the bit optimizer is going to do, it's going to have like a selling price for that commodity that you're interested in, and you have all the different costs related to ore and waste material, and they're going to be, maybe if you want to go like very complex, by lithology, and you create all of these. So the algorithm is going to calculate a value per block. So you'll have like positive values, negative values, and so on. Then what the software is going to do, it's going to try and look for what is the shell that's going to generate for you the highest profit. So that's the ultimate shell for that specific price. But now let's say that we're going to sell that the selling price is, I don't know, like $100 or $1,000 or whatever. Okay, and let's say that you want to generate like multiple scenarios. What if that selling price at some point in time is going to decrease or increase, which is going to affect the depth or the shape of that shell that you've generated for a single price? In that case, we do what we call here, like in Micromine staging, which means we're going to do like decrease or increase that selling price, and we generate different shells or a sequence of shells based on that price. So for example, if we say like 0.1, which means we're going to use just 10% of that selling price. So if we set the selling price later on to $100 and we say 0.1, the shell of 0.1, we're just using $10 for as a selling price. And the shell generated by the $10 is going to be like a really small shell and very narrow and shallow. So that's going to show us probably, or it's going to be concentrated in the area with the highest grades and the lowest depths. So we can use this as a guide later on, these shells as a guide to know where to design the pushbacks for the when we do like the pit design, the tail design. So in this case, we're going to go from 0.1 or 10% of the selling price all the way to 1.1, and the increment is going to be 0.1. So we're going to go 0.1, 0.2, 0.3, and so on. And that's it. Or if you're just interested in one single shell, you can just uncheck this one, and Micromine is going to use just that one selling price that you will define later on, and it's going to generate just one shell. But it is a good way to look at the sequence or where you should start mining and get an idea about that sequence that you might do later on when you're designing the pushbacks. Okay, now for the output, and that's the last thing for this for the first tab. Basically, you have like different reports in here. So if you go, you scroll, you can see there's a lot of templates in here in Micromine, and this is going to generate different reports. And you can go, so for example, this one that I've run earlier, let me look at this one, and you can see here what kind of information this report is going to include. So you can see that we have the different, this is the mine code that we've generated, and mine name, this is the stage, and you can see this is for the 1 and then 2 and so on. And you can see a lot of information in here that you might need or you might not, but they're valuable information. And you can also go and create a custom report and choose the things that you want to see, the things that you don't want to see. And that's it. That's for the reports. And then staging points, if you want to generate, for all of these wireframes that you're going to generate for all the different stages, if you want to generate the points, like the centroids of the blocks that were mined out, you can go and make a file for that, a point file, and you will have like the stage name field and the extraction number field in that point file. Maybe you'll need that. Maybe you want to export that to a different package, and we know that a lot of packages and they support point data, and even you can go and do your own analysis in Excel if you want. So staging wireframes, these are the wireframes that are going to be generated. They're going to be inside the pit triangulation database, and the wireframe name is going to be this one. The default color is going to be this one, and we're going to auto load that when the process is finished. Now, one option here is you can see that you have smooth surface or exact surface. So this means that the wireframe is going to use for the smooth one, the wireframe is going to use the block centroids to create a wireframe. And for the exact surface, it's going to follow the blocks, and you're going to have that blocky shape, but it is more accurate. And you can go and smooth it out or make adjustments during the detailed design process. Now for the block model attributes, these are just the things that you're going to populate these ones as attributes in the block model. So maybe you want to look at the the data block model wise. Maybe you want to filter the block model, not just look at the wireframes. So you can go and insert these fields to the block model, and so you will be able to do things in there. So that's it for this one. So let's go and save this and close. The next tab is the processing. So for processing, again, you can call this maybe open pit 1. And you can also do a code in here, maybe 0.001. And then you have the definition tab in here. So basically what we do here, it's really easy, and it's self-explanatory. You can see that we have processing cost. You can define that per ton or per cubic meter. And we have the general and administration cost. That's 1.5. Again, it depends on what currency you've chosen, whether it is dollar, Canadian dollar, or whatever. And then you can see that we have the different material bins in here. So like I've mentioned before, the material bins could be like lithologies, or it could be like classes, or whatever you want to divide your model. In our case, we've chosen like high grades and low grades, and the element is gold. This is based on the elements that we've defined in the first phase. And then the value is 90. This is for the recovery. It's 90% for this one and 89 for this one. The unit is percent. You can choose that as a factor if you want so, but it is easier to set the values and not get it wrong when you do it in percent. And then you can apply some additional costs if you want so, and the unit of the grade is ounces, and that's it. So that's for the processing. And then we go to the customers, and this is where we define the selling prices. Maybe you have different customers and different selling prices, so you can define them here. So in our case, we're going to use just one, and you can see the element. Since we have just gold, maybe you have multiple elements that you want to optimize for them, so you can use you can define them here if you want. In our case, we just have the gold. The price is 1,200. Again, this is the the currency. We need to set the currency from the beginning. What is the currency that we're going to use? This is again the unit. Just make sure to use the right unit in here, because if this selling price, for example, is per gram, and you just set it in this, for example, ounces, it's not going to be right, and you're going to have like the wrong shell, and everything that you've done is going to be wrong. So make sure to use the right unit in here. The selling cost is basically a cost related to selling that commodity we have in here, in our case, which is gold, and click on OK, and that's it. It's really that simple to do pit optimization in Micromine. Just all you have to do right now is to click on run, and it's going to take some time based on the block size, how complex you went. So you've defined maybe a lot of different custom things and custom fields, and you have like, I don't know, like 10 millions block model, 10 million block model. And yeah, so I'm gonna run this and pause it, and then get back to you guys when the process is finished, so that we can take a look at the different shells that we've generated. So see you in a moment. Okay, the bit optimizer just finished processing our inputs, and we have now the shells. So let's go and take a look at them. And you can see that we have 9 shells, that each one of them corresponds to a different selling price. And you can see that we have some sort of a pushback in here, and you can see that where we should start and where we should end our mining, or at least gives us an idea. That's not we should, but gives us a really good idea about how the pit should look like. Okay, so we know that there's some really high grades at some shallow depths in here, and we need to go toward this direction. And let's go and hide some of these shells so we can see. So basically this is the biggest shell in there. So there are 2 shells actually. This is the biggest shell, and you can see that some of the materials that was not extracted because it was not economic. So, and if we go to this one, we lower the selling price, and you can see that the pit gets shallower and shallower. That's because some of the elements that were economic with the high selling price are not economic anymore, and this really gives us a good idea where and how the pit should look like depending on the selling price. Okay, so that's not where we should. And by the way, if you click on this one and each one of these shells, you'll find a lot of attributes that in the wireframe, that you can see a lot of things in here. So for example, this is for 5, and you get stage increment that's 0.7 and so on. A lot of things in here like volume, high grade, low grade, and things like that are going to be, these attributes are going to be included in the shell. And also, if you look at the block model now, you can see that we have some new attributes in here that were generated by the pit optimizer, and they are going to be helpful when we analyze these shells. And this is not like the end. Usually you should go to pit optimizer and analyze pits and result charts, and these are things from the old version, but these are the things that you should go for. We're not going to cover these in this video. Maybe if you're interested, we can cover that in a different video. So I don't want to make this like a really long video for you guys. So you can just now know the basics, how you can generate these shells in Micromine, how you can use your input data, your geotech data, your economic data, and your block model to generate these shells, and how to change them. And as you can see, it's really simple to do bit optimization in Micromine. So, and you know now that there's not just one package that does bit optimization. There's plenty of other packages, and one of them is Micromine, and it's, you know, the bit optimizer from Micromine. It's a really great tool, and I think also it is cost effective. So compared to other packages. So that's it for this video. I hope it was informative. And if you're new to this channel, make sure to subscribe. Follow me on LinkedIn. I share some useful stuff in there. And with that being said, see you in the next video.